Now let us understand this particular concept with the help of example. Let us consider here 3-bit integer. Now this 3-bit integer, when I say 3-bit integer means what? 2 raised to 3. That means we have 8 combinations. When I say it is unsigned number system, which means all the numbers will be positive, that is from 0 to 7. When I say signed number systems, that means half of the numbers will be positive and half of the numbers will be negative, which means from 0 to 3 will be positive and from -1 to -4 will be negative values. Now in the similar manner, if I use 4 bits number, then 2 raised to 4, that means I will have 16 combinations. That means if unsigned numbers are used, number system is used, I will have representations for positive 0 to 15 number. And if I use signed number systems, that means from 0 to 7, I will have representations positive and negative representations for the numbers -1 to -8. So similarly, if I now say, can I represent +5 as 101? Is this correct or not? Using 3 bits. So if it is unsigned number system, yes, definitely 101 will be the correct answer. But we are talking here about signed number systems. When signed number systems is there, 101 will be the wrong, or let's say it is the incorrect representation of +5. Why? Because let us understand that in the above table, if you see in signed numbers column, for 2 raised to 3 or let's say 3-bit integer, what are the positive values we are able to see? That is 0 to 3. And does this 5 fall under this 0 to 3 range? No, it does not fall under this range. That is why we cannot represent +5 using 3 bits number. Now if you see here in 2 raised to 4 or let's say 4-bit integer, for signed bits representation, do you see a range of 0 to 7, which means 5 falls in this range. That means 5 can be only represented with 4 bits in signed number system. So here, which means that +5 can be represented as 0101 in signed number systems. And how will be -5 represented? -5 will be represented in its 2's complement form. Because the number is negative, we have to represent it in its 2's complement form. So for that, first we need to take its binary representation, which is 0101, then convert it into its 1's complement form, which is inverting, that is 1010, then add to it to get its 2's, add 1 to it to get its 2's complement form, which becomes 1011. Now when the number is 1011, MSB is 1, that means the number is negative, right? And this 1011 take its 2's complement form now, which becomes what? 0101. That means it is -5. So this is the example. Now I would like you to solve this particular exercise by taking the reference of this particular slide, and here you should find out to represent, let's say 26, how many bits will be required, and negative numbers should be represented in its 2's complement form. So I would like you to solve this particular exercise, and I would like to summarize this particular session. So what we have seen, negative numbers are represented in 3 ways: sign, magnitude, 1's complement and 2's complement. But the only reliable method or accurate method to represent negative numbers is 2's complement form. We have also seen why sign, magnitude method and 1's complement form method does not work, because it has the representation for -0, which is incorrect. 0 can never have negative value. However, 2's complement can represent all 8 values, that is from -4 to 3. Therefore, negative numbers are always represented in their 2's complement form. I hope I have made this clear, and thank you.